Salam and hi everyone, we meet again in this video. So today we will proceed with Thermodynamics open system, but first let's have a look at this concept map here. Okay, so what we have here is an overview of thermodynamics engineering. So you can see from thermodynamics, the main thing. So we are going to have a look at the system, the working fluid, and the law. As for now, we have already learned about, as of today, we have already learned about the system, closed, where we have two types. One is rigid tank, another one is moving boundary. And we have learned that there are 5 processes in this closed system. And when we solve our first law in closed system, we are going to reduce the term in first law based on these 5 processes. And then we are going to make sure which type of working fluid we are going to use. If it's vapor, then we are going to find the properties from the table. If it's ideal gas, then we are going to make use of ideal gas equation. Now, moving from there onwards, in this video, we are going to learn about this open system, where we have 5 common devices that use in open system, which are nozzle, diffuser, compressor, turbine, and throttle valve. And we are going to have a look at our first law. How are we going to analyze the open system using first law? And how are we going to deduce the term based on what kind of devices we are used? And then we are going to solve for the properties that we are looking for based on what type of working fluid we are used. Now, this is the notes that the lecture notes that you have about open system. So you will see that from this note you have 2 openings, one considered as inlet, the other one is the outlet, and you have some sort of fan over here that indicate works, and some sort of heating element here that indicates heat. And you have the difference of datum, where we label it as Z1 and Z2. One of the equation besides of the first law equations, when solving for your open system, this is another crucial equation where m dot is equal to density times with your velocity c and the area of A, and V here is your specific volume or the volume. So in this open system, we are going to learn on how we are going to make use of first law equations, and then it becomes the steady flow energy equations, and how are we going to apply it in the open system devices. So you can see here the term U, internal energy, and this work boundary is deduced into H is equal to U plus PV. Hence, you are going to have this kind of equation, and we call it as steady flow energy equation. From time to time, when we solve for open system, which consists of 5 devices, we will refer to your steady flow energy equation. So from the concept map, we have 5 devices. So this is the common devices that use in your thermodynamics applications. But the one that we are going to learn in this topic is nozzle, diffuser, throttle valve, turbine, and compressor. Whereas these 2 devices you will learn further in your air conditioning class. So you will see based on this steady flow energy equations, then we will determine what types of devices that we are going to use, and from there onwards we are going to deduce the steady flow energy equation becomes these equations for nozzles or diffuser, and then we have the turbines, and then compressor, and finally we have valve or throttling devices. So in the next coming video, I'm going to show you on how to deduce your steady flow energy equation in this yellow box based on what kind of devices you are going to use and what will be the final term that from your steady flow energy equation, so that you can analyze using the working fluid and solve the properties that you are looking for. Hence, before I finish this video, let's recap what should be learned in this chapter. So, learning objective of this topic at the end of this video, students should be able to describe 5 devices commonly used in thermodynamics open system by sketching the diagram indicating inlet and the outlet flow. And then you will need to find the thermodynamics properties, for example pressure, volume, temperature, enthalpy, in the open system using the first law of thermodynamics equations. Next, you should be able to deduce the terms in thermodynamics first law equation, where now it is steady flow energy equation, based on the assumption made for the open system to be solved. Finally, you will have to solve the remaining term in thermodynamics first law of open system based on the type of working fluid used. Before I end, so let's have a look at these 2 applications in our daily life. That's the introductory part of what we are going to learn in this open system, and how are we going to apply that first law of open system or steady flow energy equation to solve the open system problem. In next video, I'm going to show you one example from one open system device and how are we going to complete the learning objective. Thank you.